Let's jump into amplification and reflection attacks. And with amplification and reflection attacks, this is really a combined attack procedure. Our threat actors are going to use amplification and reflection both to create a denial service. With amplification, the threat actor is going to forward an ICMP echo request message to many hosts in number. These messages that we forward to these hosts, all these messages are going to contain a spoofed source IP address. And that source IP address is of the victim we want to hit. So while we message all of these machines, all these messages have a spoofed source IP of the actual target that we want to hit with our traffic. Now the reflection is the second half of this attack, where all those hosts we messaged respond back to the source. That source being the poor victim with the spoofed IP address that we put in our message that we sent. So what it looks like is this. Amplification goes out. Our message could be a multicast or a broadcast to a targeted group of machines. That message includes the spoofed source IP address. The reflection, all those targeted users that we hit are responding back with the source IP of themselves, but now the destination IP of the spoofed address that we had originated. And that poor victim, which had nothing to do with this traffic whatsoever, is being hit using that reflection. A good example of this would be using even a tool known as Smurf6, which is built and ran using Python. And using Python, you can even see here inside of the code, microseconds with the I modifier, interface victim IP, the multicast network address. We can actually see live Python code being used in a variety of our network attacks nowadays. Lastly, we have address spoofing attacks themselves. This is where we commonly can see non-blind and blind spoofing. And blind spoofing is the easiest to talk about because this is where a threat actor can't see the traffic being sent between a host device and the target. And in blind spoofing, we have our threat actor here trying to manipulate and utilize MAC addresses for their own DOS purposes. With non-blind spoofing, this is where we actually have a threat actor trying to hijack a session. They're inspecting the reply packet from a targeted victim. They try to determine the state of the firewall and the sequence number being utilized at that moment, and they try to literally take over and become a client using unethical means. Now, what it comes down to here regarding our threat actor is they're connected to a switch on port 2. They see the MAC address of the server that's existing on port 1. The switch right now understands that the server resides on port 1. But if the threat actor spoofs the MAC address of the server and attempts to become the server, and then they communicate to the switch will learn now that the MAC address AABBCC, which was the server MAC address, that MAC address is now inbound. It's coming in on the ingress of port 2. Thus, for the switch says, oh, I understand that AABBCC, that machine has moved and now exists off of port 2. So whenever I, the switch, must send traffic to the server, of course, I will send it out now on port 2. So we have our users, which can be legitimate. We have our threat actors, which can do unethical things, all using the same network devices and network infrastructure that our normal everyday traffic runs on.